So friend, this is our third sections of the type C controller sections, that is buck boost converter. So in this sections I am going to explain you how this buck boost converter works. So normally in our traditional laptop we seen that there is a sections called the battery charging sections, where the battery charge and the voltage come from the adapters or from the battery laptop work. So this section is something like that, so similar to the battery charging section, but the concept is little bit different. So I'll explain you how this concept works. So first of all, we see what are the components are used in this section. So we can see in the center there is one chip. It's called the buck boost controller chips. The basically the buck boost controller circuits means the increase or decrease the voltage. So that we seen in the last video that how the what is the buck boost converter, that either buck means reduce the voltage and boost means increase the voltage. So this section increase also simultaneously decrease the voltage. So for that they use a separate dedicated buck boost controller chips, and here is the chips number is BQ25700A. Okay, and here are, you can see there, these are the two MOSFET Q1 and Q2. These are the N channel MOSFET, and here is a Q3 and Q4, also N channel MOSFET. So there are four MOSFETs, and in between center there is one coil, the PL coil, the inductors is there, and this is the input of the power. So this is a type C uh, adapter, type C power coming from here, and this type C power is communicate this type C controller chips. This type C controller chips is use Realtek RTS 5455. Okay, so this chips will communicate with the type C port, and then power and the data will be delivered. And here are the loads which normally use two MOSFETs to uh, turn on and turn off the power. And then here is a, this is the current sensing resistor, the PR1, and then these are the MOSFET which I already told you. And here is my battery, and here's a MOSFET number 5. So this is a MOSFET number 5 for the charging for the battery. Okay, so this voltage is going to the in battery, and if the voltage is absent from the adapter, then what happen is the voltage pass from the battery via this MOSFET. So this B plus is the output voltage, which is called the system voltage, which is going output to the different sections. So and all these things happen via this protocol is called the SM bus. SM bus is called the system management controller bus, or it's called the I2C bus. And here is the SIO, super input output controller, which manage and control all the power. So we'll start the animation and we'll see how the things are work. So now when I connect the adapters, so first the CC line is communicate with each other. If the CC line the voltage is 0 means he want the voltage, and if the CC line is 5 volt means he can send the voltage. So once we connect the adapter, then the 5 voltages come here, which is going to this type C controller chip. Then CC line communicates, CC line request the type C adapter that how much the voltage is required. Accordingly the type C adapter deliver that voltage which is come across here. And then what this type C controller chips do is he just enable this load switch, that is the two MOSFETs are there. They turn on this both the MOSFET, and here the 20 volt will be generated. That 20 volt will be passed here, and this 20 volt is coming here and the top of this Q1 MOSFET and PR register. So this is basically, we can say, a current sensing resistor. There the 20 volt will 20 volt will come across at this resistor. Okay, and the top of this Q1 MOSFET, and that is drain. And then this 20 volt is going to this buck boost controller chips as a power, as called a DC in power supply for this chips, that is called V in, or the DC power. Okay, and then after this is, so this I written mention here a step. So you simply you have to follow the step number 1, step number 2, step number 3, like that. So this step number 6 is here, and then the step number 7 is here, that REGN, that means the regulator. So in this chips there is a linear regulator which generate a 5 volt. So once this 20 volt come across in this chips, then the 5 volt will be generated by this chip that is called the 5-volt linear voltage. Okay, so this 5-volt linear voltage will be generated, and we can say assume that if this REGN 5-volt is coming, then we can assume that this chip is probably working. So you have to check step number 7, REGN pin, you should get a 5-volt there. Okay, once you receive the 20-volt from here, and thereafter what happens, here are two resistors, this is called the voltage divider circuit, voltage divider resistor, which is the 20-volt come here, which will be divided by this resistor, and according to the Ohm's law, here will be 3-volt will be generated, and this 3-volt is going to the AC in pin. Here the AC in pin stand for adapter current in. That means this chip will come to know that the adapter voltage is present. Okay, and this voltage is going to the chips. So now the chips got this AC in signal, means he's know that the adapter voltage is present. Then after, what he do is he is informed to his boss. Now who is in his boss of this buck boost converter? So this is the SIO. So SIO. So what he do is he just generate a 3-volt. The output is called the ACOK. ACOK stand for adapter current OK. That means this chip is going to tell the SIO that the adapter voltage is present. AC present means the adapter voltage is present. So you generate a 3-volt here. So you have to check a 3-volt here on the SIO AC present pin or the ACOK pin. So 3-volt will be here. That means this chip telling to the SIO that adapter voltage is present. So once this you receive the 3-volt, then after SIO and this type C this buck boost converter communicate with each other via the SM bus, and then the on the step number 10. So if you want to check the signal, then you can't check this signal via this multimeter, so you need an oscilloscope. So you have to connect the oscilloscope or the signal analyzer, and there you will find some pulses are coming there. So if these pulses are coming, then these two chips are communicating with each other. So there will be clock and the data. This is called SM clock and SM data. So step number 10, and after that step number 10, step number 11 is SIO tell buck converter that switch this two MOSFET. Here are the two MOSFET. So this circuit is called, basically it's called the buck converter, and this circuit is called the boost converter. There is a coil is common for the both. So you can see this MOSFET number 1, MOSFET number 2, drain source, and this one is a gate, upper MOSFET, lower MOSFET, upper MOSFET, lower MOSFET, and this junction is connected to the coil, and coil is the output. So this is a buck converter, which means the reduce the voltage, and this section is called the boost converter, which increase the voltage. So the buck converter and the boost converter. So once communication will take place between the SIO and the buck boost converter, then step number 11, this chip started switching this two MOSFET, generating the pulsating AC. So here the 20 voltage started chopping via this Q1 and Q2 MOSFET, which will be gathered here, and this voltage will be passed via this inductor PL, and this voltage will be passed here. Now what is happening here? Here the two MOSFETs are switched off. That means the voltage will be stopped here. Now what this chip will do is he will turn on this Q3 MOSFET. Step number 12 will be generated. He will turn on this Q3 MOSFET, and then what happens is this pulsating AC voltage which is generated here will be passed here, and this capacitor will be filtered this voltage, and here we'll get a 13 voltage. That is step number 13. So in this way we'll get our 13 voltage here at step number 13. So here is a 20 volt, and here will be 13 volt will be generated. So this buck converter what do? He convert that 20 volt into 13 volt, which is called the system voltage. Okay. So after that, once this voltage is output, then here is a battery, and here is the SIO started communicating via this SM bus on step number 50, and the SIO asks the battery whether he need a charge or not. If the battery says yes, I need a charge, then SIO start communicating. Then the SIO start communicating via this buck boost converter and ask to generate the power for the battery. And after that, this chip, what do he do? He generate this battery drive signal. So in step number 16, you can see here step number 16, the battery drive signal, which will be out, which will be trigger this MOSFET, like this, and then the 13 voltage will be passed via this MOSFET like this and entered into the battery, and the battery started charging. So in this way battery charge started charging, and the output system voltage is going to the next sections. So in this way this type C controller works. Now what happen if we remove the adapter? If we remove the adapter, then the CC voltage will be dropped to the zero, then there is no voltage. SIO will come to know SIO will come to know that the AC present will be zero, and then what happen is this battery output voltage, which 13 voltage, will be passed via this PR2 MOSFET cross this MOSFET Q5, and this output voltage will be goes output on step number 30. So when the adapter is absent, at that time battery voltage will be passed via this MOSFET. Okay, so like this. And when the adapter is present, then voltage will be passed from this section. So this is basically called the buck boost converter. So in the type C, in this way this buck boost converter works.